Okay, so good afternoon, everyone. So today I will be the presenter of the SuperMap Mini Classroom webinar, the Volume 9. First of all, I want to introduce myself. My name is Firdausi Zarigandis. I'm the Technical Support Engineer of SuperMap Software. And thank you so much for you that already joined from the beginning when I start the room. Without any further ado, I will start the webinar. Let's start with a brief introduction of the SuperMap technology. Okay, so maybe some of you still not familiar enough with our technology. So we are basically SuperMap software is a GIS software provider, and we've been start our company since 1997. We are coming from Beijing, and for more than 23 years, we already have help human in solving various spatial problems. And also we have more than 4,000 employees coming from all around the world, more than 1,000 partners coming from more than 30 countries, and also 38 branch offices and subsidiaries. Okay, okay. First, I want to let you know regarding the five main key technologies in SuperMap. So basically, these five main key technologies will be act as a basic foundation for solving spatial problems in SuperMap software. So it consists of the first one is the big data GIS. So we support to handle the big data start from streaming, storage management, analysis, and also the visualization. And the second one is the AI and GIS integration. So artificial intelligence or GIS integration in the SuperMap, we provide three main functions. The first one is the Geo AI for GIS, and GIS for AI. Actually, we already discussed more about the AI and GIS integration in the previous webinar, in the previous SuperMap mini classroom. So if you're willing to know more detail about our technology regarding the AI and GIS integration, you could have a check in our YouTube account. We already discussed more details about these technologies. And the third one is the three-dimension GIS. So we here capable to, we already developed our function leads to 3D modeling since 2009. And we able to consume various 3D data, integrate it, and also bring them not only for desktop display, but also further for cloud-based, for example. And the last one is the cross-platform GIS. So we are able to be open not only in Windows operating system, but also Linux operating system. Okay. Okay, and for today, we will discuss more details on SuperMap technology, the oblique photography, and GIS, including for the processing, analysis, and also the optimization. Okay, now let's start with the definition of the oblique photogrammetry technology. So it's a bit different with the common acquisition using drone, if you ever know about that, and it commonly uses multiple sensors and capture image that the result can cover the whole surface of the object. There are some steps need to be done to achieve the 3D model, and we will discuss after this. And this is the automatic modeling process of oblique photogrammetry. First, after we did the data acquisition, then we need to do the aerial triangulation process and then obtain the points cloud and then process it more details to get the TIN or triangular irregular network. And then finally, we can achieve the digital surface model, and eventually we can get the oblique photogrammetry model. And in the SuperMap, we didn't cover to handle this process. We only process after you obtain the 3D model from another software. There are some advantages from the oblique photogrammetry data if we try to compare it with other maybe man-made 3D models, such as the first one is high efficiency. So we can obtain large model from large area in a short time, and then it will looks like real high accuracy since it can achieve high resolution image. and less production costs because of it. If we try to compare it with uh, manually model 3D reality, it will take longer time rather than do the object acquisition, and also the sense of the reality is of course totally different if you compare it with a man-made model. So this is only a little on how the oblique photogrammetry is more advantageous rather than a man-made model. And these are the common standard formats for 3D model. The commonly the data for coming from public acquisition is will be in the format of OBJ, OSG, OSGB, DAE, and etc. And it will be in the form of tiling files. So uh, we are we are not going to import all of these tiling file together directly in our software, but in SuperMap we need to process the we need to generate the configuration file first before we import the data, and this is also will raise the performance in load the data in our software. And for in the supermap itself, we also support to handle the sgb file, obj, and etc. This is more details on the how the 3D model obtained from oblique photography is displayed in our software. And anyway, if you have any question, you can drop your question in the Q&A chat box, and my colleagues will help me to answer your questions. Okay, this is more details. So yeah, as you can see here, we can smoothly display the data, the large data, keep the resolution so that so that it still be able to be displayed for the user. And yeah, and this is for the oblique photogrammetry industry chain. I divide it into two different parts. The first one is that done by using other software, and the right one is done by using SuperMap software. For acquisition until obtain the 3D model was done by using other software. So SuperMap is not handle the modeling process. We only handle the further step after you get the 3D model, and also provide you the optimization 3D GIS platform, and support you to do the further application development by using our product as GIS as the basic foundation. Okay, now the other question is how SuperMap able to optimize the oblique photogrammetry display visualization and also analysis. Okay, first this is a video on how we can display the oblique data. So this is SuperMap realize the efficient load and smooth display of terabyte level oblique photography modeling data, and at the same time it supports long-term and stable operation and consumes less hardware resources. Okay. Okay, this is more details on the explanation how the SuperMap able to optimize the loading of the oblique data. The first one is the merge root nodes. In order to improve the loading and browsing performance of the oblique photography, SuperMap provides a tool of merging root node, which makes the adjacent four small blocks are merged into one new and large block, and it can set the number of merges to reduce the number of root nodes by selecting the level until the performance is optimum. So like I've said before, if you're willing to import the oblique data, we will not directly import the OSGB file. We need to uh, we need to go to the step to create the configuration file first, and it will be according to your object data, and the result will be one configuration file in the form of scp format, and then the scp format this file will be used to import the data by using our software. And also the other things is the texture compression. So we provide a compression tools that compresses texture data from oblique photographic data to texture compression format. Sorry. And then the third one is the generate S3M or the spatial 3D model. So the SGM is will be suitable to for loading the WebGL, which can improve the browsing efficiency. And also we support to convert the HGB within the SCP file into the S3M or the spatial 3D model data after the texture compression, root nodes merging, monomer creation, and etc. Okay. And of course, our capability is not only for desktop-based analysis or display, but of course we can bring your Oblique data for a cloud-based platform so that the user can be able to share or publish their 3D data for another user in online way. So this is we are using WebGL to publish and share the 3D model data. Okay, the next, and of course, this is will be the last one, the distributed processing methods. So, in order to meet the needs of users, SuperMap GIS is based on the distributed technology, which implements the distributed storage, combined distributed file system, and distributed database, and distributed operator transformation of oblique photography models. And it will avoiding the multiple input and output and achieving efficient full process management, including for the data access, data processing, multi-terminal applications. It helps real-world 3D construction so that it can realize efficient storage, management, and processing of terabyte or petabyte massive 3D data. So here we are able to it's kind of divide the workload of either for storage management, analysis, or visualization for into several machines so that it will raise the performance to display or analyze your 3D data by using this distributed concept. Okay, after this, I will show you the live demonstration of how SuperMap handle the 3D model analysis from Oblique acquisition. And we will use the SuperMap iDesktop latest version, the 10.1.1 version. And you can download our products in the link I put in this presentation. And don't worry, I will show the material later so you can download the PPT also from that link that also contain the link to download our products. And this is the workflow for today's session. First of all, I will show you how to generate the configuration file and then do the project transformation, open the 3D model in spherical scene, do the effect repair encoding for clip and replace the texture, and also create the monomer for display and spatial query. Okay, and this is a brief on how we generate the configuration file. So for the oblique data, oblique 3D model that coming from the oblique photography, we can realize the direct loading and browsing OSGB model data by loading the 3D model cache file of .scp. So without any further explanation, I will go directly to my iDesktop. Okay, yeah, this is the visualization of SuperMap iDesktop. The latest version, the 10i 2020. So first, I want to let you know how we can generate the configuration file. To do so, you can go to the 3D data and under the oblique photograph tab menu, you can click the data management and generate configuration file. Okay. First, you will be asked to open the source data. You can open the path maybe I would like to show you how the data looks like. It will be looks like this. Mm. So the data is will be in the form of tiling file in the HGB format, something like this. In the total, it will be around 1048 487 data. So we will not going to import this all directly to the software. Instead, we will create a configuration file first and import the configuration file. Okay, so that's why we generate the configuration file first. So select the source path. Okay, and then you can define the result folder, maybe here. Okay, and then the name file. And should you already know the center points of your 3D model, you can directly put the information here. Okay, and this is I already know the center points of my 3D model, so I can directly put them in here and click OK. Okay, and as the process completed, you can open the configuration file by create a new spherical scene first. Right click in the general layer and add OSGB cache file. This one, and click open. And you can zoom the layer, and this is how the data looks like. Yeah, as you can see here, maybe because of the limitation of teleconference, it may looks not smooth enough, but actually here I can smoothly drag the object. Okay, okay, now go back to the presentation. So next is because of for in some cases is that the data was created in another software before we import to the SuperMap iDesktop, and they used to define the projection is in ENU Spatial Reference, which is a local coordinate system. So they define local center points in their particular area. But if you're willing to do transformation from the ENU spatial reference to the projected coordinate system as you desired, we also provide the ENU to projection toolbox, and you can use this toolbox to transform from the ENU spatial reference to the projected coordinate system that provided by SuperMap. And it will be done according to the metadata file that provided by the creator of the 3D model. Okay. But for this case, since I don't have the metadata file, so I just want to skip this step because I also didn't want to transfer my data and go to the third step, which is actually I also already done to open the data in the spherical scene by add the OSGB cache file and import the SCP file that we already created before in the first step, which is the configuration file creation. Okay, next is about the effect repair. In the effect repair, the step is quite simple. So first, you will need to find an area to be repaired and then draw a polygon on it, make it flat. And the last one is change the texture. And it will allow you to put some 3D symbol on it. So because of SuperMap also provides so many 3D symbol you can use, such as for water, trees, flower, highway, car, railway, and etc. So you can implement that in your 3D model by by change the symbol of your vector file, such as here in this example is we are going to change the water symbol of an area from vector file. And we also already provided the tools for this process. So if you go to the 3D designer, we have the HGB processing here, and we provide some processing toolbox including the clip, hollow, mosaic, linear extrude, and also the texture replace. But because of for today, I will not show you how to do the hollow, mosaic, and linear extrude since I don't have the data that support the toolbox. But instead, I will show you how to do clip and also change the texture. Maybe we will start with the first one is the texture repair. So now we already have the texture replace toolbox window in the right side. Okay, please make sure if the input is the SCP file or the configuration file we made before. And for the area, there are two ways to display. The first one is by manually drawing the area, or if should you already have the area in the form of vector file, you can input them also. But we will use the drawing instead. So maybe we can try to looking for an area that looks like water and try to repair them, such as this one. Okay, here we can draw an area, a polygon like this. Since doesn't looks good, I will try it again. And right click when you're done. Okay, so this still in the form of polygon, and we are going to change the texture by using the 3D symbol provided in SuperMap. So here, this is a temporary file, so this will automatically add as a temporary file, this one, and you can change the style. Right click on the layer and change the layer style. And here we provide some basic fill and also the 3D symbol. If you go to the 3D fill tab here and fill library 3D, here we provide some 3D symbol for water. You can use that to achieve the water repair. And I will use the calm lake instead and click OK. Okay, I will try to zoom the layer again. Okay, let's draw again. Okay, yeah, as you can see here, the water texture is changed. It looks like a calm wet water, right? And we also provide another 3D symbol such as for trees, for highway, for flower, and etc. And you can use that to do some texture repair for your 3D model data. And another things we can do is also did the clip analysis. So if you go to the 3D designer, like before, you will find the clip toolbox here. And actually the concept is just clip the 3D model based on the area you have drawn. Maybe this one. So here we try to clip the area based on the polygon we have drawn before. Maybe another art area. Such as this. Okay. Okay. Next, let's go back to the presentation. Next is about the monomer. So this is a very good feature in our products to achieve spatial query, and also another tools such as achieve the thematic mapping or others in for the 3D model data. The problem is that it starts with the problem is that the 3D model obtained from Oblique acquisition is a continual TIN. The single object cannot be selected in GIS platform. But by achieve the monomer display, monomer object for your 3D model, we can get further analysis for your model, such as to do spatial query, thematic mapping, attribute query, and etc. There are three types of monomer. The first one is the split monomer, the second one is ID monomer, and the third one is dynamic monomer. So, but in the SuperMap, we only support for the ID monomer and dynamic monomer. What the differences are? For the split monomer, it will create the monomer based on the object contour vector data to generate the monomer, while in the ID monomer and dynamic monomer, you already have the vector file of your 3D model data, and in the ID monomer, you try to assign the value from your vector data to your 3D model, and in the dynamic monomer, you claim your vector data to the 3D model by using our feature claim to object. And we can further achieve analysis for by using this monomer, such as for to do the query attributes by object, query object by attributes, make a thematic map, or buffer query. So we are did this by using the monomer object. And further analysis is like this one. So we also able to achieve the object query for 3D models by using by overlay the vector file of each story, which then will be overlay each other and storage for each floor. So finally we can obtain the 3D model for from your vector file, and also overlay it with our model data, so that if you're willing to do some query analysis for your 3D model data, you can achieve that by using monomer analysis here. Okay. Okay, first, I will show you the dynamic monomer first. So the step is quite easy. You only need to import your vector file and then set it to claim to object, so that you can be able to achieve the monomer display that will help you to achieve the query analysis. Okay, here I will open my existing vector file and add to this current scene. Okay, I will change the order, and it will be located automatically beneath the 3D model. And now I'm going to change the altitude setting of this vector file to be claimed to object, this one, and change the order. So now it will be claimed to the 3D model. So if you have a click in each vector file that already claimed to the 3D model, you will be able to get the object information. Okay, we open the properties first. This one. So yeah, so now maybe if you haven't claimed any vector file to your 3D data, you will not be able to know whether uh, you will not be able to know what is the information for each building here. But if you have the vector file, and also clamp it to each object here in your 3D model data. And if you have a click on each file, you will be able to get more information of each building beneath the vector file, something like this. And also achieve some query. Achieve some query, so you can go to the spatial analysis, query, and SQL query. Can here, just like the common query, maybe we are going to select a particular building where the building number, for example, 43, and highlight the result in the scene and click query. And it will show you which one is the building with number 43, like this one. Okay. And the last one is the ID monomer. So in the ID monomer, it quite different with the dynamic monomer. So in the dynamic monomer, we try to clamp the vector file to the 3D model so that it will look like the 3D model covered by the vector file. While in the ID monomer, we only try to assign a particular value from the vector file to the 3D model. So we are going to use the compression and monomer toolbox. So it will not only create a monomer but also create a compression file in the format of spatial 3D model format. And it also will be useful for you if you are going to bring your 3D model data uh, for a cloud-based display purposes, such as by using WebGL. You can create the spatial 3D model cache file first by using this toolbox. So later on, after we obtain the cache file, we can directly import the cache file in our iDesktop. And once we click the 3D model, it will show you the value that assigned it from the vector file in compression and monomer uh, step. Okay, if you go back to the SuperMap ID stop here. Okay, you can go to the 3D data and there is a compression and monomer, and the input is will be the configuration file we have created before, and then you can change the type here, either STM or STMB based on your requirements, and then define the target path. And also, if you're willing to create the monomer, also you can have a check in the model discrete checkbox here, and change the target field, and it should be in the form of integer format, maybe building number, and click OK. Okay, before while we waiting for the compression and monomer creation, it may take some time. The last slide will explain to you about the 3D analysis that can be performed for your 3D model data. So we also provide some 3D analysis such as feasibility analysis, skyline analysis, flood analysis, viewshed analysis, or building limit analysis, and etc. in for your 3D model data. So these analysis are not only for oblique photogrammetry data, but also for other 3D data as long as they can be consumed in our software. Okay, but there is important information is that for some analysis that need elevation information such as the flood analysis, slope and aspect analysis, or maybe isoline analysis, they need elevation information from your 3D data. Should your data has no information of elevation model, elevation information, so you cannot perform that analysis. But for feasibility analysis, skyline analysis, or maybe viewshed analysis, these analysis no need any elevation information, so you can directly perform that by using ready-to-use toolbox in our software. Okay, so I think the process was done already. So we can open our result by add the OSGB cache layer again. And this one it will be the result. And click copy. Okay, and yeah, we can remove or turn off the layer, the other layer, and it will only remain the result of the monomer and compression process. So if we can change it again here. So the vector files should be located here, right? But after we did the compression and monomer, once once we click the particular 3D model, it will show you the ID that already assigned for each 3D model you have done before. Depends on the location of the vector file, such as this one. And this one is the building number we have assigned in the previous process. But since my vector file is not cover the whole building here, only a part of it, so that I'm not be able to select the whole building. Wait, let me try again. This one. So if we have clicked in this building, it will show you the ID information we have assigned before. Like this. So that's are the difference. For the dynamic monomer, we'll only try to clamp the vector file to the 3D model, while in the monomer compression, and it will allow us to get the ID monomer, so that you only need to click the object and you will be able to achieve the information and you will be able to get the information for each building that assigned that already been assigned by refer to the vector file. Okay. And the last one is the 3D analysis. So here we have the 3D analysis tab menu that provides some spatial analysis such as slope analysis, isoline, flooding analysis, feasibility, viewshed, and etc. In here, some analysis are need elevation information such as the slope and aspect analysis, isoline, flooding analysis. These analyses are need elevation information. But for this case, since my data has no elevation information, it has it doesn't have the digital elevation model or the digital surface model, so that we will not be able to achieve these three analysis, because these three analysis are need elevation information. But should you have your oblique data along with the digital elevation model data or the digital surface model data, you will be able to achieve these three um, elevation analysis as well. Okay, now we will try to perform some analysis. Maybe we can have a try the viewshed analysis. We will ask to draw the first and the endpoint, and it will give us result on where area that intangible from these points and which are area that tangible from this point. So the green area means that it can be seen from this point, while the red area is means that it cannot be seen from this point. Maybe uh more another things we can draw is the multiple, so we can draw directly multiple view shed, or another things is the dynamic view shed. If we draw the start and the end point, so here it will give you a simulation, people walking from the start to the end point along with the view shed result, the red area and the green area. Red the area that cannot be seen by these people, and green area is area that can be seen by these people. And you can do further setting for this view shed, such as maybe you willing to change people with car, or maybe with plane or other object. You can change it here, the role here, and also change the another parameter such as the visible distance, the uh, horizontal people reference, or maybe the place setting, because this is a simulation, right? So maybe you can set some speed or the total time and etc. You can set it further here. And maybe I would like to show you one more analysis, the shadow analysis. So we will be asked to draw a polygon, and it will show you the result. This is the sunshine rate. So the result of the shadow analysis is a 3D point with information, the XYZ coordinates, and also the daylighting rate. The daylighting rate, it depends on the elevation. So the more red the color, it will have the more daylighting rate. This is 62. Maybe the blue one is lower, 8%, 54%. So depends on the elevation. Okay. So yeah, I think that's all for today. So I have shown you how to import the 3D model oblique photography data by create the configuration file first, and then if you're willing to transform the coordinate projection system into some the common coordinate projection system from the local projection spatial reference, you can achieve that by using our toolbox. And then if you're willing to do some query for the 3D model data, you need to create the monomer first, either by using ID monomer or the dynamic monomer. You can achieve that by using our software. And maybe if you want to try it by yourself, you can download the material by link I've attached in this presentation. And if you want to get certificate from our company, you can submit your result to the link I've put in this presentation before the due date. Only participants who submit their result that will get a certificate from us. And should you have any question, you can ask your question to me by send email to my email gandes@supermap.com. Okay, I think that's all for today. Thank you for you all to coming to this SuperMap mini classroom webinar. And should you have any question, you can put your question in the Q&A chat box, and my colleagues will answer your question. Thank you, and see you in the next SMC.